In today's lesson, we are going to resume solving and graphing inequalities. But in today's objective, we are going to solve and graph inequalities by grouping like terms. We're going to review some of the concepts that we already know when applying strategies to equations and applying those same strategies to solve inequalities. So in this equation, we are going to group like terms in order to isolate the variable. So we are going to group like terms. And what does like terms mean? It means that we're going to look for expressions that share common terms. For example, this is a variable expression that shares an a. And it is similar to this variable expression that also has an a, which means we can combine these together. And similarly, these are constants, so we want to group them together. So we want all the variable expressions on one side, and we want the constants to be on the other. That's the process of isolating the variable. So let's go ahead and bring our variables to the left. So since we added 3a, the inverse would be to subtract the 3a, and we want to apply it on both sides. Since we moved the variables to the left, we then want to move the constants to the right. Opposite sides. So if we're subtracting 72, we're going to add 72 to both sides. Add 72. And when we reduce everything, positive and negative 72 cancels out. Positive 3a and negative 3a cancels out. So now we have 5a equals 85. And since we're multiplying that a by a 5, the inverse would be to divide by 5. So our answer is a equals 17. And we know that equations and inequalities are similar in that one uses different symbols. But the concepts and strategies that we use to solve an equation can be applied to inequalities. So let's take a look at what that looks like. So here we have an inequality that uses a greater than symbol. It has variables and constants just like our equation. So that means we can group like terms just like we did earlier. So let's decide we want to bring our variables to the left. So then we want to move our constants to the right. Subtracting an 8h, the opposite would be to add the 8h to both sides. Since we are subtracting a 49, we want to add a 49 to both sides. And if we want to reduce all our terms, these cancel out. We have all of our variables on one side, and we have our constants on the other. So we have 11h is greater than 66. That means that if we were to apply the inverse, or divide by 11, we get h is greater than 6. So that is applying this idea of grouping like terms in order to solve our inequality. Let's also remind ourselves, how do we apply the distributive property to the same type of inequality? So when we see that there is parentheses, we know we need to distribute to each term inside it. 6 times 2 is 12. 6 times a negative 5s is a negative 30s. Is greater than or less or equal to, is less than or equal to negative 5s minus 338. And if we were to solve that equation, we're going to end up with negative 14 is greater than or equal to s. Notice that when we were to solve this equation out, there is going to be some flipping of the signs because we divided or multiplied by a negative. But I wanted to just skip to this part because I want to remind ourselves on how do we actually graph our solution. So let's go ahead and pull out that number line. We're going to now plot anywhere on our number line, negative 14. We have this is negative 14 is greater than or equal to s, which means s is less than or equal to negative 14. We just wanted to flip it on this side to make sure that we're talking about our graph in terms of our variable. So if s is less than or equal to negative 14, it has that equal to expression, so it's going to be an inclusive, so we're going to use a closed circle. And since it's less than that value, we want to shade to the left, because all values to left would give us that less than. Otherwise, it would be greater than to the right. So now we want to let's practice together in solving an equation that uses the distributive property, and we have to group like terms. So I want to walk us through this. We have parentheses, which suggests that we need to use the distributive property. It's 11g minus 210 is greater than or equal to 20 minus 12g. So we want to combine our terms together. So we have add 12g on this side. So we want to add 12g on the left side as well. Since we're moving our variables to the left, we want to move our constants to the right. So let's go ahead and add 210 to both sides. So when we do that, we get 23g is greater than or equal to 230. And we divide both sides by 23, and we get g is greater than or equal to 10. So let's go ahead and graph that. Here's our number line. We have a 10 as our marker, so let's go ahead and label our number line with a 10. We have an equal to expression, so that is inclusive. We want to include that 10, so it's a closed circle. It's greater than, our variable is greater than, so we want to highlight our values to the right, because all values to the right of that 10 is going to be bigger. Otherwise, it would be less than. Let's see if you want to give it a shot. Now it's your turn. Remember, we want to group like terms, which means in this we have to group our variables together and our constant together. So I'm going to help you out by labeling our variables and constants so you know exactly what to group together. Now, just by looking at this equation, I see a lot of negatives. So I'm going to precaution you that if you end up multiplying or dividing by a negative, not adding or subtracting a negative, it has to be multiplying or dividing. If you end up doing that, you need to make sure you switch directions of your inequality. I want you to solve this and see where you end up. What is your inequality and what would it look like on the number line? And if you're finished with that, I want to give you a challenge problem. Again, this is a multi-step problem. Not only do you have to distribute, but you need to combine terms on one side before you can group them with the other side. This is a little bit more challenging, but I know you can do it. Good luck. Make sure you apply grouping of like terms and distributive property. That's your hint. Let's see who comes up with the right answer.